All right, everyone, happy snow day. Thanks for watching the 6 notes. Pause it right here and copy these properties down for a trapezoid and an isosceles trapezoid. All right, now that you've copied these down, I'm just going to quick remind you of a couple things. One, you can always pause, rewind, and listen to again anything I say here, so I am going to go kind of quickly because I know you're watching a video and you can do that. One other thing, in a trapezoid, actually, I'm going to talk about this first property. Exactly one pair of opposite sides are parallel. So in this case, these two are your parallel. So AB is parallel to DC. And in this case, so we call those parallel lines the bases. Okay, that's like the worst drawing. So these right here, I'm drawing a little trapezoid here. Okay. So these right here are your bases, the parallel lines. All right. Your legs, that's what they call them here. These are your legs. Okay. Just keep that in mind. So, same side interior angles are supplementary. So if we know that these are parallel here, right? If those are parallel, then we know that then this could be a transversal, meaning these angles are same side interior, meaning that they are supplementary. So angle A is sup to angle D, and same thing here, this could be our transversal. Angle B is supplementary to angle C. So we have that. Now, so those are the two technical properties of a trapezoid. There's this third thing about the mid-segment. Still important to know, not technically a property. The mid-segments of a trapezoid, quick side note, mid-segments are the segments that connect the midpoints, right? Pretty self-explanatory, midpoints of the legs. So the mid-segment of a trapezoid is parallel to each base. Remember, the bases are already parallel to each other, so the mid-segment is also a parallel line. The second part about the mid-segment, so actually that's the first part. So AB is parallel to MP, which is also parallel to DC. Okay, so that's part one. Part two is that the measure of the mid-segment, should say its measure, right, typo. Its measure is 1/2 of the sum of the lengths of the bases. So in this case, PM, the length of PM would be 1/2 of the sum of the lengths of AB plus DC. While that might look kind of overwhelming to memorize, just keep in mind it's just pretty much finding the average. So for example, if AB is 5 and DC is, I don't know, 17, PM would then be 5 plus 17 over 2. You're just finding the average. 22 over 2, which is 11. That kind of makes sense, halfway between 5 and 17, right? Okay. Isosceles trapezoids are a special type of trapezoid, and if you have not filled in your quadrilateral family tree yet, I think that would be helpful, so you can take a look. Some quadrilaterals are trapezoids, and some trapezoids are isosceles trapezoids. What makes an isosceles trapezoid? Well, if each pair of base angles are congruent. So remember, if these are our bases, because there are parallel sides, the angles that are off the same base angles are congruent. So angle K is congruent to angle L. And then same thing over here, the angles that are from that base. So angle M is congruent to angle N. Legs are congruent. Remember, legs are these right here. So KM is congruent to LN. And diagonals are congruent. So here, if we draw our diagonals in, KN is congruent to LM. One other nice thing to know, so those are congruent. One other nice thing to know is that those little parts, so like that top little part of the diagonals, are congruent, making a cute little isosceles triangle. Same thing down here. These would then be congruent, making a nice little isosceles triangle. Okay. We're going to scroll down to these practice problems. I'm just going to do number 1 with you, which is trying to find angle D. Keep in mind, if these are your parallel bases, this could be your transversal. So those are the same side interior angles, and they have to be supplementary, so that must be 55. And another thing that we know about trapezoids is that the base angles are congruent, so that also must be 55. Okay, you're going to do something very similar for number 2. Number 5, well, we skipped 3 and 4. It's all right. Number 5, if HJ is 32 and LK is 60, find MN. All right, well, it says MN are the midpoints, meaning MN is a mid-segment. So I know the mid-segment means MN is equal to 1/2 of, or I kind of like to do it the average way. It doesn't matter. 60 plus 32 over 2, which is 92 over 2, which is 46. Okay, that's my answer for that. Very similar in number 6. The only thing in number 6 is you're given 18, and you're given this is 28, so you have to be careful and make sure you're reading. You're finding LK. Meaning we know what the midpoint is, right? So we're not trying to find the midpoint. We're trying to find what you add, what one of the bases is that you are adding to find the midpoint. You can solve for x there. I'm going to give you a second to write down these properties of kite. All right. Go ahead and pause. Make sure you wrote those down. And so, properties of a kite. 2 pairs of adjacent sides are congruent. So they're talking about this right here and this right here. So you would label these as segment MP is congruent, well, not MP, MR is congruent to RP, as well as MN is congruent to NP. And those are already labeled here, right? Okay. Next, we have diagonals are perpendicular. So MP, this is a diagonal right here, is perpendicular to RN. One other nice thing to note about that is that means they make right angles. Long diagonals bisect opposite angles. So this is my long diagonal. It is bisecting the shorter, or the opposite angles. So that means this long diagonal splits these opposite angles in half, and this one in half. So go one pair at a time. So angle MNR is congruent to angle PNR. That's talking about these two right here. Then angle PRM is congruent to angle PRN is congruent to angle MRN. And that's talking about those two right there. Short diagonal is bisected. The short diagonal is bisected by the long diagonal. Okay. I also just kind of like to say the long diagonal bisects the short diagonal, whatever you want to say. Just know that this short diagonal right here is bisected. So those should make them 3. These are congruent right here. So if we label this point in the middle Q, let's say, we would say then that MQ is congruent to QP. Okay. 1 pair of opposite angles congruent. So the opposite angles connected by the short diagonal are the congruent ones. So angle M is congruent to angle P. In fact, I should name that better, right? We don't know what angle M is. Angle NMR is congruent to angle NPR. All right. I'm going to do a couple of these with you. So it says find measure of JRK. So measure of JRK is right here, this angle. Well, I know the diagonals are perpendicular, meaning they make right angles. So this must be 90 degrees. RJ is 3 and RK is 10. Okay, one quick thing to note, if we don't remember the Pythagorean theorem. So Pythagorean theorem. Remember, if we have a right triangle, and it's a right triangle because it has a right angle, we can label the legs A and B, and it doesn't matter which one you label, A and B, as long as you label the hypotenuse, the side that is opposite from the right angle, as C. The Pythagorean theorem says A squared plus B squared equals C squared, which is going to be helpful here because we know the diagonals are perpendicular, meaning that's a right angle, meaning we have a right triangle right here. So if we call this X, 3 and 10 are my legs. 3 squared plus 10 squared equals x squared. And if you go to try to solve that, that's 9 plus 100 equals x squared. 109 equals x squared, and that means x is equal to the square root of 109. And if we could simplify that, then we would, but we can't, so jk is just the square root of 109. I'm going to do one more of these with you. If angle JHJ, so that's this one right here, is 90, and GKJ, this one down here, is 110, find HGK. So we're going to find this right here. One thing, a couple ways to do this. One thing I know is that this angle and this angle are congruent. So I'm going to call them both x. Another thing I do know is that a kite is a quadrilateral because it has 4 sides, so the interior angles must add up to 360. So I'm just going to set that up. These interior angles adding up to 360, and I am sure you can solve for x. And then from there, I believe you should be able to do 4, 5, and 6. Real quick, I do want to look at number 7. Give the most descriptive name for. This is where, if you do not have your properties memorized, which, by the way, you should, and I cannot plead with you any more than I already do, to please, please, please memorize these properties, you will have a very hard time on the test if you do not have these properties memorized, which properties belong to each shape, okay? So, give the most descriptive name for a quadrilateral with diagonals that are perpendicular bisectors of each other. So, the only thing we know about this quadrilateral is stuff about the diagonals. Well, if they are perpendicular bisectors, that means the diagonals bisect each other. That means that this is a parallelogram, right? Okay, could it be more specific? Not only do they bisect, but they also are perpendicular. Do either of these parallelograms have perpendicular bisectors? Oh, yes. I'm sorry, perpendicular diagonals. Yes, the rhombus does. So not only is it a parallelogram, it is a rhombus. I'm going to have you cross out B because we'll talk about it in class. You're going to do C and D. You want to see what you come up with. For number 8, what is the most descriptive name for each quadrilateral shown below? Now remember one of the tests, so let's look at A. One of the tests for parallelogram is that one side is congruent and parallel, so this is a parallelogram. We do not know any of the other things. We don't know if this is a rhombus because we don't know if all sides are congruent, the diagonals are perpendicular, or the diagonals bisect the angles, nor do we know any of these rectangle properties. We don't know if the angles are right angles or the diagonals are congruent, so we can't say it's a rectangle, so we just have to leave it as a parallelogram. I'm going to do one more with you. Let's do E. So E is talking about the diagonals. The diagonals are obviously bisected because these are congruent as well as these, right? So it's a parallelogram because the diagonals bisect each other. The other thing I've noticed is that not only are the halves congruent, but the entire diagonals are congruent, right? So what shape has the diagonals congruent? That is a rectangle. So that right there, part E is a rectangle, okay? I know it's not a square because we do not know if E is a rhombus. If E was a rhombus, according to my properties, we would have all the sides congruent, all the diagonals perpendicular, or the diagonals bisect the angles, but we don't know any of that, so we cannot say that it is a rhombus. Or, yeah, a rhombus. So go ahead and work through number 8 as well. Good luck. What I'd like to see by the end of your snow days is all of these problems completed. So we did most of them, but I want you to do the few extra and then finish those homework assignments. Good luck. Period 7, expect a pop quiz of naming and listing the properties of a rectangle, or I'm sorry, of a rhombus and a square. That's all in your assignment center. See you guys Friday.